the process, how to get the job done, okay? First thing, you have to know how to working on Excel. Left, okay, to make sure to get the status must be passed. That's the first step. Don't try to worry about anything. Okay? After you get that status passed, then the next you guys to develop your test program to test that circuit. Okay? And after you done for your test program, compile no error and ready to run. And now you can build your circuit and test the circuit with your test program. They must be following those steps, okay? And when you test the circuitry fail, how can you fix the problem? Okay? For anyone, okay, in the tech queue, either they already been here for a while, okay? And now I can get another thing. I will be asking you, if the test fails, you have to tell me what you want to do. We not try to recommend to you to take the wiring. No, we don't care. Only take the wiring when the test fails. Okay? And if you get any problem from the beginning, you can ask me. Either you can text to me to get on the Zoom or whatever. I helping you to solving the problem. Okay? And try to help you how can we do it. And everyone's supposed to be online. Otherwise, I will be drop you out for this semester. Okay? Make sure you understand that.
Okay.
Okay, so the first thing I will be talking about quickly to lab today. That means the lab 7 and the lab number 8. Just a minute. Okay. So the first thing is this lab will be lab number 7, BCD counter. Now, any lab using the PSPI simulation. So we don't care much about, the circuitry. But we have to know for each test and what involved on that test, okay? On this circuitry here, when you're looking into that, and you have to know how many IC you want. Okay. And this is timing they given to you. So you can using that to get the output of the circuitry in here. Okay. And after you get output from simulation, what you need to do, you have to enter the data port A, port C, in this case, into this port A and C. Okay. Basically, you get information from this part here. Okay. Then you have also complete the data here, the quiz. They can asking you whatever until you get that one. Started part. Okay. That is the process you have to do. Proceed. So you get any question that will be also relating to the lab number 4 or the lab number 5 or the lab number 6 that is still using the simulation. If you run the simulation, you get a wrong data or the status cannot pass. Okay? You can contact to me. I can help you out very quickly. Okay? After you get all of the data, it passed. What you need after that to code in your program, only one you want to code in your program will be using data in port A or port B or port C or port D. Okay? Complete that. And this one only using for your coding that program. We can forget everything. We don't care. But when you code it, you need port A, port B, port C, port D. Okay? Now, if you want to test the preset for this circuitry, and you understand this have to be 0 and the clear mode be 1. Okay? If you write to port A, pin 1, 0, pin 2, 1, and the output, you can see this is a 1 output, 2, 3, 4. All of that must be 1. So when you run your test, they fail. Maybe you can get 0 here, 0 here, 0 here, 0 here. Now, what can we do? Okay. If you understand, then you can do this way. Using the meter to measure E1 pin 2, pin 7, E2 pin 2, and E2 pin 7. They have to be 0. That means they can get any voltage less than 0.8 volt. So, for example, when you measure L1 pin 2, you get 1.2 volt. Can you tell me what you think you can do? Repeat it. You're using the meter. Measure L1 pin 2. You get 1.2 volt. What can we do?
Replace the IC?
No, not yet.
Hmm.
First thing is you don't have any digital level for 1.2 volt. Logic 0 less than 0.8 volt. Logic 1 have to be higher than 2 volt. You don't have any logic 1.2 volt. Okay? So you know something must be wrong. So now you can take L1 pin 7 to see what logic you get. If you get also 1.2 and another 2 more in here and in here, still get the same. Okay? That means you get 1.2 volt. What next you want to do?
Check the input.
You have to check dry at the PA pin 1. Okay? To see what you get PA pin 1. If you get 0, that means 0.1, 0.2, 0.3, 0.4 volt. That means PA pin 01 is good. So I can guarantee the wiring from PA pin 1 to either U1 pin 2, pin 7, U2 the same. Must be missing the wire. Okay? However, you get at PA pin 1, same thing, 1.2. Then what you think you can do?
Replace the box that we're testing, the unit box.
Yeah. That means you can try to reset the control box, right? Reset it, press reset it. After you reset, then at least in the control box, 2 LED have to be linked. If they not, that means the computer not talking to the box. Okay? That's what we already did yesterday. The control box is not talking into the computer. Then you can change another box. However, that box have to be put on my desk. I will be checking to fix the problem. Okay? So yesterday, we can the box everything part. Okay, still not done yet. If you test the 4 preset, you apply 0 here, and that will be 1. And now you get the static fail. When you check the U1 pin 2 pin 7 to 7, they on logic 0. They 0. But they still fail. Tell me what next you want to do.
Check U1 pin 3 and U1 pin 8.
Okay, U1 pin 3. You perfect. U1 it have to be logic 1. Correct?
Yes.
Okay, so you can check U1 pin 3, pin 8, or pin 3, pin 8 for U2. Make sure they have to be logic 1. Okay? If it's not, then you have to fix it. Make sure PA pin 02 must be 1. And now you see, look like everything okay. 0 in here, 1 in here, okay? And the output, they coming out, okay? You can get a 0, 1 here, 1 here, 0 here, 1 here. So the test still failed. Now they fail on U2 pin 50. You want it to be a 1. Okay? So what you can do, you can take right here to make sure you get either 1 or 0. If you get a 0 here, that means something wrong with this guy here. Okay? So now you can take on this IC U2A. Okay? Make sure you get the power and make sure you get the route. Power for this IC will be pin number 5. And route will be pin number 13. That we already talking in the lab, inside that one. If you look like you get everything okay, what can you do? You measure here, here, here. You measure, preset okay, clear okay, power okay, route okay. How come the output is not right? Tell me what you want to do.
I mean, the clock, would the clock have anything?
No, this is not clock, right? The
Mhm.
thing is preset override everything.
Oh,
Okay? Or clear, override everything. Preset 0, Q must be 0, no matter what. Clear 0, Q must be 0. Okay? Preset 0, Q must be 1. Clear 0, Q must be 0. Not depending on anything. No clock, okay? No input at all. Nothing.
So it would be the IC.
Perfect. You can get another IC. Okay. And sometimes lab instructor will be asking you, how come you want to change that? You choose. Then you can say, okay, I get the preset 0, I get the clear 1. And I get power, I get ground. Okay? So that's why I need to change IC. Now, when you change IC, still same problem. Last thing telling me what you can to do to solve the problem. You can YouTube and you rerun it, still fail the same. Who can telling me what can we do? That later on, not for your new tech you on the own tech you, they have to do it. Okay, that means they have to tell me when something wrong. How can we fix the problem? In order to get a final for certificate.
Those is U3 relevant?
I mean, if
U3.
no, we don't get U3 right now. We're talking about you fail on U2 15, right? You take power, you take ground, you take input here, you take input here, everything okay. That's why you're asking for a new IC. And you can get IC and rerun it, you still get 0.
Would it be a problem with PC 3?
PC3. That means you're talking about PC3, right?
Yes.
Okay. You can say maybe wrong with the PC3. That's the one, also the good one. Okay. But what can you do? You
Check the software.
Or is it the motherboard? The internals are, the wiring is wrong. Replace the whole motherboard. Would that be correct?
no. Right now you fail only one. U2 pin 50. Don't you already change the IC? They still not working. So someone told me you can take the PC pin number 3. So whatever you get from here, that's why you suppose you get the same on PC number 3. You already change the IC. You already take the power, ground. You already take the preset and clear. Look like nothing wrong.
Do we get a different box, test box, or no?
No. You just
Would it be the wiring going from 15 to PC3?
exactly. That is the one I want to talk to you. Now, if I have to do it, I using the meter. Okay? To ring out the wire. So, first thing you can connect one, go to U2 pin 50. Okay, and you can go to PC pin 3, make sure they ring it out. However, you ring out the wire. You have to remove 5 volts from your circuitry. Okay, then you can ring out the wire. And make sure pin 15 go to here. That's okay. And they make sure they go to L3 pin 13. Okay. And you can bring it out anywhere wiring in here to guarantee they not connect to somewhere else. And also make sure you can bring it out pin 15 to the round. Make sure they're not shorted to the round. Okay? That is you can fix the problem, guarantee it. At work, you don't care about the wiring. However, this is the lab working in the program. You build it. That's why you have to worry about wiring. Okay?
Okay, so in this scenario, the last thing we would check is the wiring. If we did all the
Yeah.
steps, wiring
Well,
is the last step.
Exactly.
Okay. Okay.
But check a wiring only to pin 50. Correct? Not try
Yes.
to take every wiring. That's not the technician job. Only take pin 15, not connect to the ground. Not connect somewhere else they're not supposed to go. Okay? That will be fix the problem.
Yes, sir.
That's what I want to think. Now you take for clear. 1 here, 0 here. And the output supposed to be 0, 0, 0, 0. And now you can get more easier. Okay? If they fail, you can do the same. Make sure pin 3, pin 8, pin 3, pin 8 supposed to be 0. Okay? And pin 2, pin 7, pin 2, 7, make sure they be 1. However, sometimes you can see they fail on this one only. They not 0, they 1, for example. Then you only working on L1. Okay? Make sure pin 7, pin number 8. Correct. Okay? And make sure pin 11 is 0 or 1. They're supposed to be 0 and did not 0. Then that's a wiring. But that not happen. Okay? The thing is you already passed that number 1. Okay? So if you know how to do it, then you're looking into the fail method. You can see you know which pin is wrong. And you're working on that. I don't want to see anyone fail try to go to take on the wiring. That is not your job. Okay? The last one, counting. If the counting fails, like you counting to number 1. 1 here. 0, 0, 0. So if you not get 1 here, then you can take L1 pin 15. Make sure they 1. Okay. Or you can tell any output queue what you have to do. That means they're not counting. Just quickly telling me what you want to check.
And the clock.
When you run start counting, they're not counting. In here, you see that? That's number 3. Count for clock number 1. They counting. They're not counting. Tell me what you want to check. Before they already 0, 0, 0, 0. And now for counting, you're supposed to get a 1 here, for example. And the last will be 0, but they're not. What can you do?
Check pin 15 first of view 1.
Yeah, good. I don't think that will be, you need to check the thing is why. They already passed that for 1, and they already passed for that for 0. So the wiring guarantee will be okay.
Oh.
Would we check the connection for the end clock
No,
at the input?
not talking about connector. You're using the meter right now. When you start counting, they're not counting. Telling me what you want to do. Okay, you understand it on this tab, you will be applied and clock will go this way. 1, 0, and clock. Okay, without the clock, counter cannot count it.
So we check for end clock on.
Now you have to check to see if you get it wrong or not wrong for end clock.
Mhm.
That's what I try to teach you. You get a true way to solve the problem. For end clock, the thing is, when you call the function end clock, and when you see it, you didn't see end clock anymore. Okay? That means you cannot see the high to 0. So what you can do, you can using the software. I will be helping you later on. You can adding this few lines. When you run, they keep apply the clock. And you have to using the oscilloscope to see U1 pin 1. You can see square wave. That means the clock keep going. So that will be help a lot. You can check U1 pin 1, make sure you get a square wave. That means the clock. U2, U1 pin 6, U2 pin 1, U2 pin 6 guarantee on get the clock. It's hard to using the meter to see that signal. The thing is when you're using the meter to connect into U1 pin 1, you see nothing. The clock already done. That's why you have to using oscilloscope. But we have to add a few lines. I will be let you know. Okay? How to adding that to take for the N clock or either P clock same way. That is the one way. The other way, also I will be teach you using the, when you run, you will be run with the debugger. That means when they run into that, apply the clock, you can connect the meter into pin 1, up U1. And you press F10, they go to the next line. Or you can press F11, they go inside and the clock. Okay? And when you press F10, you can see the clock going, they go to 0. If you press F10 again, they go to 1. Okay? So that is the way either technician or engineering, we have to learn how to do it. That means debugger, not without. Okay? And I will be teacher guide. Okay? For the next meeting. Okay?
Okay.
So this is the way how can we working. Okay, any question regarding into lab number 7?
No questions.
Okay, the lab number 4, the same thing, lab is 7. Number 5, same thing. Number 6, same thing. The thing is we're using the simulation. Okay, so now quickly I'm talking about the lab number 8. Right now I try to explain to you. This lab no simulation. The thing is we don't have a part in the library. So this lab basically requires understanding. First thing, if you're looking into this circuitry, how many IC?
5.
5, right?
Yeah.
Okay. First thing, let's see, how many input from port A? You can see port A pin 1, 2, 3, 4. Okay, 5. Okay. That means you're using port A, 5 pieces. On port C, how many?
Five.
5.
5. You can see right here. 1, 2, 3, 4. Here will be 5. That is the first thing you need to identify. Okay. Now we can go into a little more detail. First thing, you know, U1, 74, 125. What is it? Did they explain anything in here? Right here. Did I see? They just a buffer. Okay. They're telling you inside this IC, you get 1, 2, 3, 4. Forget. And that will be telling you. Forget you get A1, pin 2 in, pin 3 out. Pin 1 will be a control. And the truth table telling you everything here. Okay. Control if they low. Input low, output low. Input high, output high. If the control at the logic 1, output will be high impedance. That means you get a big resistance at the output. So they cannot loading anything. Okay. So that's a very simple for this IC. And now U1 or U2, they already route for control. That means they enable all the time. You get a 0 here, you get a 0 out. You get a 1 in, 1 out. Nothing else. However, only the difference will be sometimes you get 2.5 volt input, okay, and the output supposed to be also at the logic high, but they can bring up to 3.2 volt. Still logic 1, but you want the logic 1 close to 5 volt as much as we can, okay? So that's why they're using the buffer. Just bring the output to the standard logic state, okay? Therefore, U1. Now I'm talking about U5. How many pins for U5 here?
20.
20. Correct? And pin 20 will be 5 volt. Pin 10 will be round. That's normal. Okay? And they get how many input?
4.
1, 2, 3, 4, 5, 6, 7, 8. Is that right?
Yeah.
How many outputs?
4, 7.
Cannot be 7.
Well,
8, right?
Yeah.
Okay, if you want it, you can look into here. Okay, you can see that. That's 244. Okay, you can get 8 input and 8 output, and that controlled by pin number 1 and pin number 19. Okay, that will be telling you. Now, if you get input here, 1, 0, 1, 0. Okay, then control pin 1, pin 19. Okay, pin 1 will be control that one, 19 will be control second one, and now they already routed. That means the control will be allowed. Whatever coming here will be coming to out here. So the output here, they will be 1. Okay? And this will be going back to here. Okay? Will be 1, 0, 1, 0. That's how this IC working. Or if you get the data on this input here, they will be go into that output here. That's the job for U5. They just allow input go to the output. Okay, if you get the pin 1 and 19 routed, if they not routed, they not at the 0, that means the output will be high impedance. Same thing like normal buffer. High impedance, that means they get a very big resistance. Okay, at the output, so they cannot loading any current. Okay. So U4 74LS191. Okay, that's the counter. You're looking into here. Try to understand. When you're looking into the timing, this is the data input A, B, C, D. And this is the input load. And this is the clock. And this input D yield. That means count down or count up. Okay. 0 and count up. 1, they will be counting down. Okay. And output QA, QB, QC, QD. Okay. You get 4 output. And also, you can see you can get max minimum RCO. Let's see, counter here. RC, that means, let's see. U4, they get a 4 input, 4 output Q. Q0, 1, 2, 3, okay? And you get another 2 more input, okay? 1 will be TC terminate counting up, okay? And also RC. Normally, this line RC here will be at logic 1. When they go to 0, that means this counter already counted. Same thing for pin number 12. You want to understand, you need to see this timing here. First thing, you want to get the load, and the load must be applied 0 here. And now you can see A input logic 1, B 0, C 1, D 1. That means you get 1 0 1 1. Okay. So when the load going low, okay, then the output you will see 1 here, 1 here, 0 here, 1 here. That means you load it. So basically you want to loading the data, you just apply load 0 and apply whatever A, B, C, D. Then they will be going to the output. That's the load. Don't need anything else. Okay, let's see. Okay, if you're looking into that thing here, you can see pin number 14, that will be clock. Okay, the clock supposed to be positive, not negative. Okay, so that's why you get P clock. Pin number 4, CE enable. They routed, that means they are allowed counting anytime. Pin number 5, when you're reading, you see the bar over U and a D. That will be telling you pin number 5 0, they count up. Pin number 5 logic 1, they count down. Okay, that's for counting. And the flat PL active low, that means if you get a 0 here, whatever in the P0 to P3 will be go to Q0 to Q3. Okay. Now, if you want to count up, first thing you're looking into the timing. Load must be 1. Okay. Load is the highest priority. If load 0, you cannot count anything. So you want to count load must be apply 1. Okay. And you can see they give an example here. They load before load number 13, 1101. When they start apply the counter, they go to number 14. 14 will be what? 1, 1, 1, 0. Okay. And they will be counting up. Okay. 14, then they counting up to 15. And they start count 0, 1, 2, 3. Up to 15, go back again. However, we're looking into here. Okay. You get 2 things. That one here. And that RTO. Normally, this line, the 0. When they go to 1, by looking the timing. Who can tell me? I just want you to know how can we looking at timing and you able to understand. My question is the output max minimum. Normally the 0. When they go to 1,
Would it be the maximum of the
counter.
counter?
Perfect. You can see they count 14. Then they apply the next clock, they go to 15. You can see 15 right here, right? QA, okay, will be 1, 1, 1, 1. Okay, you can see that. Then they go up. Okay, they going up. And they going low when you start count to 0. So if I'm looking into that output here, when they go to 1, I know the counter already done for 1 complete counting up to 50. Okay? And also, I want to know RCO output. When they go low, normally they 1. When they go low,
Would it be the start to the next counter? Or
now when the QA equal 1, 1, 1, 1, right? Then
Yeah.
they go to the maximum. Then the max and minimum, they go up. However, this will be going low. You see that?
Yeah.
Okay. So when you go see it going low, okay, they're telling you, both go 1. Okay. And if you understand later, you can see this one when they count down. This one going up when? Okay, let's see. QA here. 1, 0, right? 0, 0. Okay. And up to this point here.
It hit minimum.
Yeah, when the countdown go to minimum 0, then this guy going up. And this guy will be going low. Okay? If you can try to learn how to reading the timing. That's what you have to do at work. You get the IC. You don't want to know. You can go Google. You can type that IC. They can give you own information. And that's what you have to know in order to do your job. Okay? That's for count up or count down. Okay? And now what you need to do. That's what they want you to do. Follow reading that one. Okay? They say no simulation. Okay? And after you get that thing done, okay? The key or whatever. And then you go into that one here. That's what you need to fill in port A and port C. Okay? Make sure they can be part, right? And finally, this will have to be part before you want to do anything else. Okay? And after you get it part, forget everything. You using only data in port A and in port C to coding your program. And compile, make sure no error. And now you can build a circuit. Okay, any question, anything?
No.
You see the way doing lab will be exactly almost the same. Okay. However, your guy right now in tech two did a full tech two going back like normal. That means you have to get more digital labs, not like the other only few people get up to 14 that be completed. However, your guy can go up to 20 or more. Okay, so you get any question, okay? If it's not, when you're working on, you get any problem, either on Excel, that means you cannot get it back, or you get a problem when you're coding your program, okay? Then I said, you can text to me. Need help on the lab, whatever. I can online with you. Maybe just about less than 30 minutes, then can solve everything. Okay, any question, anything else? Okay, if it's not, then we will stop the lecture for today. What I can tell you, if you get a computer at home, you can code in your program, you can work at home, okay? You can analyze anything at home. However, when you get into the class, okay, then you can test your circuitry. You can build at home also, okay? That saves you a lot of time. Have to come into the class. When the class going back to normal, that means everything have to be in the class. That we will spend a lot of time trying to go to the class, okay? But I don't think that happened at this time. Maybe next year, maybe. Like before the COVID-19, the class will be working normal. Everything happen will be in the class, okay? So before we stop it, you get any question? No?
No
I do have one
questions.
question.
Yeah.
When will DLab 9 be on the website?
Can you say again?
When will DLab 9 be on the website?
When the D-Lab?
9, number 9, yeah.
Oh, number 8 right now. Number 9 will be next week.
Okay.
That's what I'm working on. Okay. However, we'll be giving you a little more hard time. Okay. However, for this lab in here, okay, I will be working with you one by one in the lab. That means I try to let you run the lab, and this part that I'm talking about, the lab, my lab, not your lab. Then I can make something wrong. When it fails, you get to tell me what you want to do. Okay? If you still cannot, that means you have to still working on that thing. What we want to do, try to be a real technician. That means deal with the problem. Okay? You have to understand that apply from this semester. I spent a lot of time to thinking how can I helping you like myself. When I see something wrong, I know right away what to do. That really the way I want to get up to that point. Okay? Anything else? Well, okay, if it's not, we will stop it and we will see you next week in the class that we normally I will be in the class on Tuesday. Okay, and the Zoom lecture will be on Wednesday. Okay, so good night, everyone.
Good night, Mr. Friend.
Good night.
Okay, we'll see you. Good night.